I was always, I think, from when I was very little, just liked being outside and doing things in nature, and liked learning about how the planet works. So if we think about sea level change, we have our instrumental record, which includes satellites, and that record goes back around 20 or 30 years. And then we have our tide gauge record, which at best goes back around 100 years. What I'm trying to do is extend that instrumental record even further back in time over several thousands of years. To do that, I use salt marshes. So I do a lot of field work out in salt marshes on the coast of New Jersey, and go out in these marshes and take sediment cores from the top where you have the newest sediment down to the depths where you have the oldest sediment. I look at little geological and biological indicators in these sediment cores and track sea level change over time. If you go out in these upper creeks and tributaries, you see these areas of all these standing dead trees within marsh areas. We're calling these standing dead trees ghost forests. They're sensitive to salt water, so when they're exposed, they tend to die off. And then when you have big events, like a big storm, like Hurricane Sandy, you get even bigger die-offs of these areas of trees. Sea level has been rising in New Jersey over several thousands of years. So this process has been occurring that whole time, where you have this shift in ecosystems. The difference now is that sea level is rising at much faster rates. You're losing these forests much more rapidly, and compared to several thousand years ago when there weren't humans, now these ecosystems can't just shift backwards. They run into human developments and agricultural lands.
So I'm going to look at you, not at this.
Yes.
Actually, all the farmers down there, they talk about before and after Sandy. That's like almost like, it's a major historical event in their lifetime. And their whole concept of how they farm has totally changed post-Sandy. So storms and tides, groundwater extraction, all of these sort of culminate in this phenomenon called saltwater intrusion, which is the landward movement of sea salts. And we see this in forests, and we see this these migrating marshes into uplands, and then we actually see farmlands also turning into marshes. We lost 1% of the agricultural land in 8 years. So it's pretty dramatic what's been happening. And this is the information the farmers want. When I'm out there, they're like, Kate, I want a map of my field, and I want you to show me where it's gonna be in 5 years so that I can start making decisions now. Some of the farms we work on are the first farms of the United States, and they're also the ones that are the first to go underwater. And so to me, there's something like very moving about the history that we're losing, the history that's going underwater, and that the livelihoods of some of these people have been tied to the land for generations.
So this is called an eddy covariance tower, and it can measure whether the carbon dioxide is coming out of the marsh or going into the marsh. You can see all that mud right there, but that mud keeps going down meters upon meters, and that's all very organic rich sediment. So it's essentially carbon dioxide that's transformed into a solid form that's removed from the atmosphere. And so these are essentially our carbon dioxide sinks.
Oh, gotcha.
And so that's one of the reasons I'm particularly interested in studying them, is understanding if we lose tidal wetlands, you might re-release that stored old carbon and get us further from our baseline and goal of greenhouse gas reductions.
Tidal wetlands are typically considered to be resilient to changes in sea level rise. But this, of course, is in an unprecedented time where sea level rise is at a rate slightly faster.
So what we're really interested in looking at is, as sea levels rise, are our marshes keeping pace? And so we have the infrastructure and equipment here to try to address that question.
Tidal wetlands do have the ability to vertically accrete, so this is when sediment comes and can build elevation so that it can keep pace with the sea level rise.
This is measuring the vertical position of the marsh, and so they're lowering pins down to the surface and looking at the change in how far that pin goes down over time.
If that rate of sea level rise is faster than the rate of that vertical accretion or that sediment deposition, then you start to lose your tidal wetlands and you get open water. So it depends. We're still actively working on figuring out what tidal wetlands may mean, but so far we are projected to be losing tidal wetlands more than we are gaining them. There's many initiatives in the Mid-Atlantic where we're working not just as an individual state, but as an entire region, which is very important because climate change doesn't abide by jurisdictional boundaries. It doesn't just stop at Delaware. So working together with our neighboring states is very important to understand the big picture.
My concern is that saltwater intrusion may exacerbate some of the nutrient loading. Salt is very complex, and it's going to totally change the chemistry of your soil. So if you have a nitrogen molecule that's hanging out in your soil, when we're in the lab and we want to extract that nitrogen from a soil sample, we add salt and we shake. So now all that nitrogen is easily moved in through the tidal creeks, through the ditches, and maybe even into the Chesapeake Bay. Of course, in Maryland, we worry about crabs and we worry about oysters, so those are also major industries. And so any kind of chemical change or anything that might change our ability or impede our ability to grow or cultivate some of these, our fisheries, our oysters and our crabs would be a huge problem for Maryland. It's not going to get better. So we have to think about, what are the strategies that they can employ now, and then also, like I said, planning for the future. So maybe it would be best to do something now, even if saltwater intrusion hasn't hit this field. We know it's going to be there in 5-10 years. What can we do now to maybe remediate the problem? And all the farmers are super amenable to having those conversations. So, of course, we subsidize corn, soy, and wheat in the United States, and none of those are going to grow very well in saltwater intruded fields. So now we're talking about sorghum, switchgrass, barley, and all of those have markets. And so we only selected crops to test that we knew had markets in the field. We actually are trying some other crops in the lab. We have to sort of start with what farmers are willing to plant, and all the crops we selected with farmers. Thinking about carbon storage, could these farms, this one's I'm really excited about, could these farms be the next blue carbon ecosystem? So could we manage our farmlands for carbon storage? Because if they're going to be a marsh anyway, is there a way that we could make them even better at holding onto carbon, which would serve this climate change mitigation aspect? So that's something that I'm really interested in, but every day we open up another can of worms and there's another question, but this research is going to be going on for a while.